All right, folks, this is Mr. Walker here coming out with our next round of notes for angle bisectors. So, starting off, an angle bisector is a line or a segment that divides an angle into two congruent angles. Now, we're going to go through how to do this on the camera in real life, but just understand that whatever you see is going to be able to cut whatever angle we are looking at into two parts. All right, I'll see you in just a second. Hello, folks. Let's go through and construct us an angle bisector. So we're following along with the instructions from our paper. Let's follow along with us in this video. First, we draw an angle. That's done for us. Next, you're going to place the point or the circle part of your compass on the vertex. Our vertex here is B. And we are going to open the width of this and draw an arc that intersects both sides. Now, for this arc, it does not matter what size these arcs are. Just make sure that you don't adjust it for our next two. So here's our first one. We have to make one that hits both sides of our angle. So here we go. That's both sides of our angle hit right there. Now, after I do that, I'm going to label these two places, these two intersections, as D and E. Next, I'm going to go through and place my compass on D, and I'm going to make an arc that hits the middle inside of our angle. So, it doesn't matter how big this is. Honestly, if you don't want to adjust your compass at all, that's perfectly fine, because this will work for this. So, I made a little arc inside. Now, once I make that first arc, I then come over to E, and making sure that I don't change the size of this, I make another arc right there. Now, once I have these two arcs intersecting here, I take a straight edge or a ruler or just something that's straight and draw a line connecting from our vertex to that intersection. So here's our line. And this line has actually cut this angle in half. Now, just to verify that we have cut it in half, I'm going to measure this out with a protractor. So here's our protractor. This line, no, sorry, not this line. This angle is originally around 60 degrees. And our angle bisector that we just made would have cut it right around 30. And that actually worked. Okay, that worked out good. Thanks for watching. Follow along for our next one. Hey, folks. So if you followed along with us, you saw that when we see our bisector, no matter where you actually go through and do this, you don't actually have to go through as much eyeballing and measurements that we've done in the past ones. But the main things that you need to look for are where those arcs cross and that your line goes from your vertex to where that cross happens. All right. Now, jumping through, we have our new point of concurrency. If a point is on an angle bisector or the bisector of an angle, like it says, it is equidistant from the sides of the angle. There are three angle bisectors in a triangle, and the point where they intersect is called the incenter. Now, just like how the name says, it is going to be inside of our triangle. So each of these lines are equidistant from whatever the sides of the angle that we are cutting. So keep that in mind for where you have to set up some math. All right, so talking about some theorems with this, we have our angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from both sides of the angle. So over here on our picture, we have this point C. C is on the bisector of this angle ABD. And if I go through and look at one side of the line, if they give me a number here, it is the same number that'll be right here. So if this side's 12, so is that. Now, along with these, in the converse of this, we have if a point is in the interior of an angle and it is equidistant from the sides, then it is on the bisector. So if you see a point and it's equidistant from the sides, you know that it's on the bisector. Lastly, the angle bisectors of a triangle intersect at the point, the incenter, that is equidistant from the sides of the triangle. So remember, that incenter is going to be equidistant from the sides of our triangles. Now, going into our last little bit of practice here on the bottom. First off, it asks you for the location of where the incenter is on these different types of triangles. And honestly, just like the name says, it is going to be inside of your triangles. Now, for these two on the bottom, I did kind of went through and did a little bit of scratching on these when we went through these together in person. But if you didn't know, we have an angle bisector here. And if they give me one length of the line, then this other line that they give me from the bisector to the side is also the same. Likewise, over here, they give us an example of the incenter. Now, since this incenter is on the bisector of this, since this incenter is on the inside of this angle here, L, since from here to the side is 11, so is this side here from to this side. It is also 11. So just keep that in mind as we go through it, that equal distance is the name of the game as we go through it. Thanks for watching, folks. I'll see you for our next one.